Can anyone summarize? Anybody? Anybody wish to summarize what we have discussed in yesterday's lecture? Quickly. Pratiksha Khobre.
सर मैं कल एब्सेंट थी.
Okay. Rutuja.
Yes, sir.
हाँ. नाव घेतल्यावरच बोला असं काय आहे का मॅडम?
सिस्टम फंक्शन फाइंड करने के 2 एग्जांपल्स लिए थे.
We have discussed in yesterday's lecture like how to find or how to convert analog system function to a digital system function, that is h of s to h of z, using a bilinear transformation. Hope everyone has understood. Anybody is having doubt in that part? Have you understood?
No, sir.
Okay.
Yes, sir.
Okay. So what is that answer? I have given you one question. Can anyone tell me the answer such that we will verify with others and we will move ahead? कोई बताएंगे
Yes,
मुझे
sir.
answer?
Yes.
Yes, please. Tell me the answer.
H of z equal to 7.45 z square.
Just a minute. Huh? I will just write it down so that others will understand. Okay. What is that? H of z equals to
7.45 z square
7.45 z square
plus
Ah.
0.4 z
plus 0.4
4 z
z
minus 7.05
minus 7.05
divided by 64.50 z square
64.50 z square
minus 87.045 z
87.045 or we
Z.
will take 87.05 we will take z plus or minus
plus sir 58.70
58.70. Okay, your roll number 8 na
12 sir
12. Okay, A12 is the answer, this one. What about others?
Yes, sir.
Same answer.
Roll number
8.
A8,
19.
A19 or
5.
10.
A5, A10,
A56.
A56. Okay,
A28.
A28. Who else again?
18.
Huh?
A13.
A13. Okay. Who else? Only 8 members. Huh?
A29.
A21. Okay. Next.
A29.
A29. Okay.
A26.
Huh?
A20.
A20. Okay. Who else again? Okay. So this is what I think. There is no problem with the questions now. And what about others? I think I don't know whether you have tried it or not. ट्राई किया तो बहुत अच्छा हुआ, नहीं किया तो उससे अच्छा हुआ, राइट? अभी उससे ज्यादा कुछ बोल नहीं सकते यहाँ पे. Okay, so can I move to the next topic today? Hope you understood or you are cleared with the examples of how to convert h of s to h of z using bilinear transformation and how to convert h of s to h of z using inverse invariant method. Yes or no? Are you clear with these 2 points now?
Yes, sir.
Okay, let us for summarize, we will go first. Like let's just give me the answer for this. For converting h of s to h of z, we'll summarize those things and we'll move further to the next topic today. For impulse invariance method, we'll just summarize impulse invariant method. How we are performing this? Can anyone tell me? कोई बताएंगे मुझे यहाँ पे? We are h of s is equals to, if we have the function like s plus a divided by s plus a square.
Excuse me, sir. Screen share नहीं की sir.
स्क्रीन शेयर नहीं किया है क्या? ओके. Is it okay now?
Yes, sir. Yes, sir.
Okay. Now, if we have this method, like for this impulse invariance method, अगर आपका ये standard form ऐसा है, so then we are writing it like this. तो इसको हम कैसा कर रहे हैं? Like a1 divided by some factor plus b1 divided by some factor we are calculating. Yes? Yes or no?
Yes, sir.
Then we are
Yes.
calculating the values of this, and by using what is the function? 1 divided by s minus pk is in analog form, that is analog nature, that we are writing it as h of s will be converted into h of z. How we are converting that? 1 divided by, can anyone tell me? कैसा convert कर रहे हैं इसको?
1 upon 1 minus e raised to p kt into z inverse.
Very good. 1 upon 1 minus e raised to p k t into z inverse. Right? So this is what we are doing with the help of impulse invariance method. So this is the simple thing you need to remember. Understood? Any difficulty here?
No, sir.
Okay. Then this is the one method we have discussed. Then second one we have discussed with bilinear transformation method. What is the change we have done in that part? If we are solving with a bilinear transformation, if it is a bilinear transformation, then what we are doing change here? Please remember the methods. क्योंकि बहुत सारे लोग एग्जाम में इसी की वजह से कंफ्यूजन होते हैं, आंसर सॉल्व करने के बाद भी उनको मार्क्स नहीं मिलते हैं, राइट? So strictly you have to follow the method here. The question which is asked by, suppose if it is asked by bilinear method, then you have to solve it by bilinear method, or else if it is asked by impulse invariance method, then you have to solve it by impulse invariance method, right? अगर आपका ये, sorry, this is h of s है ना, is going to be h of s, not h of z. This is h of s. Now, suppose if the given transfer function is of this form, then how we are converting in bilinear transformation? What is the method we are using here? Can anyone tell me? For bilinear transformation, the transformation used is h of z equals to h of s. What we are writing here? At, what is the transformation used?
2 by t in bracket z minus 1 upon z plus 1.
2 by t in bracket z minus 1 upon z plus 1. So ये what we are doing here, we are doing this with the help of this bilinear transformation. Hope you understood the difference. If impulse invariance में और bilinear transformation में difference समझ में आया अभी?
Yes, sir.
And you may expect these question as MCQ also. They will ask you the transformation used for bilinear transformation is, मतलब h of z equals to h of s, where s is replaced by the value 2 by t, z minus 1 divided by z plus 1. This is for bilinear transformation. And the suppose in the case of impulse invariant method, the transformation used to convert analog system to the digital system or the z domain is, we are writing it as simply 1 divided by s minus pk is going to be written as 1 divided by 1 minus e power pk t z inverse. So this is for impulse invariant method and this is for bilinear transformation method. So this is the difference between these two. Clear?
Yes, sir.
Okay. Now can I move to the further topic? We just write the one more topic which is there in this syllabus. Just write the topic as today's analog low pass filter design. Analog low pass filter design. Just write the title as analog low pass filter design. Analog low pass filter design. Okay. So here, as we all know the definition of filter, we know the definition of analog, we know the definition of low pass, and here we are designing that part. Okay. Hope everyone knows the meaning of the title. Filter का मतलब क्या है यहाँ पे? What is filter? What is filter?
Which passes desired band of frequencies.
Which passes desired band of frequencies. Okay. So आप लोगों को बोलने लगाने के लिए मुझे ऐसे छोटे छोटे क्वेश्चन भी पूछना पड़ता है. Right? So what is low pass filter? What is low pass filter?
Passes low frequency signal.
Which passes the all low frequency signals up to cutoff frequency. Okay. Then hope you all know the analog. Analog किसको बोल रहे हैं हम? What is analog signal? Can anyone define it? What is analog signal? Anybody? What is analog signal?
Continuous signal. Analog signal is continuous signal.
Analog signal is continuous signal. Okay. Is there any difference in analog and continuous? Or both are same? Whether analog and continuous? Chalo, let me draw it. So this is the signal, right? And this is also the signal. अब इसमें एनालॉग कौन सा है और कंटिन्यूअस कौन सा है? Yes? Can anyone tell me? Let us write this as x of t with respect to t, and this is, let me write like v of t with respect to t. Now Which one is analog signal and which one is continuous signal here?
X of t is analog.
X of t is analog. Why? Why not V of t? So based on your answer, I have written like analog signal is continuous signal. Okay, no problem. So why V of t is not analog signal? Anybody?
Because it doesn't have a specific time interval.
Which one? V of t.
Yes.
Yes. Here यहाँ पे अभी main difference क्या है इसका कि all analog signal can be called as continuous signal, but all continuous signal cannot be called as analog signal because the signal which can be defined mathematically, ये signal को mathematically express कर सकते हैं, right? I can write this signal mathematically, so I can call it as analog signal. Is it possible to write this signal mathematical form? V of t को हम लिख सकते हैं क्या mathematical form में?
No, sir.
No. So it is, we can call it as a continuous time signal. इसको continuous बोल सकते हैं लेकिन analog नहीं बोल सकते हम. But here this I can call it as analog signal because this part I can write it as a mathematically. So I can write it as x of t equals to sine t or simply sine omega t in general way. So this way. So this is the main difference. Understood?
Yes.
साला का clear था? Okay. Now, I think this thing I told while discussing our signals and system also. I don't know, no one has remembered that. मेरा नसीब है वो, क्या कर सकते हैं उसके लिए? Okay. Then let's move ahead. Now let us continue with this our title, that is analog filter design. So here basically there are before going to that, you just write one line. The most general form of analog filter transfer function is, you just write one line. The most general form of analog filter transfer function is, the most general form of analog filter transfer function is, we'll write it as h of s is equals to, transfer function का definition क्या है? h of s is equals to, what is the definition of transfer function? N of s divided by denominator of s, that is numerator function divided by denominator function. Or it can be simply written as summation I equals to 0 to m, and this equation we have used many times, AISI divided by 1 plus summation I equals to 1 to n, BISI, right? So this is what a general transfer function for an analog filter. This is the general transfer function. We can write transfer function for analog filter. Okay. Analog filter it is. Let us call it as equation 1. Let us call it as 1. Here, just write one line. Here, h of s is, here h of s is the Laplace transform. Here h of s is the Laplace transform of the impulse response h of t, of the impulse response h of t, that is, we can write h of s is equals to integral minus infinity to infinity h of t, integral minus infinity to infinity h of t into e power minus st into dt. Let us call it as equation 2. H of s is the Laplace transform of impulse response h of t, that is h of s equals to integral minus infinity to infinity h of t e power minus st dt. And we just write one more line, and it has to satisfy n should be greater than or equals to m. The value of n should be greater than or equals to m. It is n should be greater than or equals to m, must be satisfied for a stable analog filter, the poles of h of s should lie in the left half of the s plane. Left half of the s plane. Okay, so this we will understand here. What is s plane and all these things. मतलब क्या है अभी यहाँ पे, सपोज आपका ये दिस इज व्हाट द प्लेन वी आर हैविंग, राइट, इसको हम एस प्लेन बोल रहे हैं. सो एस इक्वल्स टू व्हाट वी हैव नॉर्मल, इट इज एस इक्वल्स टू सिग्मा प्लस जे ओमेगा, right? So this is, if we have the value like sigma and this is j omega term, now all the poles should locate on the left side. तो यहाँ पे अगर poles आएंगे आपका, so that we are calling it as simply the stable system. It is that we will understand with the examples again, right? So have you noted? So these are the general things we need to remember here. The transfer function of low pass filter and how we are getting that by applying a Laplace transform to impulse response. Okay, next title you write. So actually there are the different types of analog filters are there, like Butterworth filter is there, Chebyshev filter is there, but according to your syllabus we have only like Butterworth filter needs to be studied. Next you just write analog low pass Butterworth filter. Next is analog low pass Butterworth filter. Analog low pass Butterworth filter. So this I will remove here. Analog low pass Butterworth filter. It is Butterworth filter. Okay. Now here, so we need to understand its characteristics, Butterworth filter characteristics. Just a minute. Before going to start with that, we will just draw one diagram. Are you able to see this?
Yes, sir.
इसको ड्रॉ करो. Then we will go further. Is all things are visible proper? Or you have any confusion here? So this is magnitude h of e power j omega versus omega we are plotting. And this is the magnitude part and this is the omega here. Or have you finished this?
Yes, sir.
Yes, sir.
Okay. Now here let me keep this diagram here as it is, or we'll just 1 minute. This I will do it in this way. Right? Now with this we will understand exactly. ये डायग्राम रख के हमें लिखना है अभी. Okay. Now you just write one line. What you have written after diagram? Have you given the name for that? The name is low pass Butterworth response or the magnitude response you can write. Low pass Butterworth response or simply the magnitude response. Okay. Now, you just write one line. This you may expect as a MCA question again. The Butterworth filter have, you just write it in points. Butterworth filter have very smooth pass band. Butterworth filter have very smooth pass band. And it is also called as, maximally flat response. It is also called as maximally flat response. This maximally flat response is the other name of Butterworth filter. It is also called as maximally flat response, full stop. Whereas Chebyshev filters are having Chebyshev, 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 Chebyshev filters are having sharp transition region, and not a smooth pass band. This we will understand, like these sentences are clarified by solving, after solving the examples. Okay. Next line you just write. Next line. A Butterworth filter is characterized by its magnitude response, its magnitude response, that is magnitude h of z is equals to 1 divided by 1 plus omega by omega c whole square, that is 2 to the power n, and whole to the power 1 by 2. 1 divided by 1 plus omega by omega c 2 to the power n whole to the power 1 by 2, where n is equals to, where we can write n equals to 1, 2, 3 dash dash dash, where this n we are writing it as n is order of the filter. We are writing it as order of the filter, and omega c we are writing it as, what is omega c here? Anybody? Omega c is cutoff frequency. Omega c is cutoff frequency of the filter. Cutoff frequency of the filter it is again. Okay. Are you getting my point? Let us call this as equation 1 here. Now, based on this equation 1, we need to write, or we need to understand the characteristics of this Butterworth filter. Are you getting my point? Are you able to understand what I am writing and what I am telling? Magnitude h of z equals to 1 divided by 1 plus omega by omega c to the power 2n whole to the power 1 by 2, where n equals to 1, 2, 3, where n is, we are calling it as order of the filter, and omega c, we are calling it as the cutoff frequency of the filter. Now, based on this equation, we will write down the characteristics of this analog filter. And also, you just write the figure A shows, figure A shows, the figure A shows the magnitude frequency response of, figure A shows the magnitude frequency response of Butterworth filter. Figure A shows the magnitude frequency response of the Butterworth filter. Okay. Now, the following observations are made from figure A. The following observations are made from figure A. In that, first one, the following observations are made from figure A. In that, first one, let me write it this way. Okay, the first point, magnitude h of j0, magnitude h of j0, sorry, what you have written here, so this will be hello, are you able to see what I am writing, all those things? हेलो, दिख रहा है ना?
Yes,
सब जो
sir.
वाले है ना?
Yes.
So actually just make this one correction here. This is h of z नहीं है वो, z h of z बोल के आदत हो गया अभी. This is h of j omega. We are writing this as a transfer function for analog filter, right? So h of j omega we are writing. Now this thing a correction. Have you made this change? Instead of z, you just make it as h of j omega, as we are writing it for analog filter, right? So magnitude h of j0 is equals to 1, for all the value of n, for all value of n. क्या मीनिंग है इसका? For all value of n. So what I have done here, magnitude h of j0, मतलब क्या हुआ अभी यहाँ पे? If I take omega equals to 0 in the equation 1, क्या होगा वैल्यू उसका? Magnitude h of j0 is equals to 1 divided by 1 plus 0 आ जाएगा अभी यहाँ पे. ठीक है? So that is the first point. What we are writing is magnitude h of j0 is equals to 1 for all value of n. Understood this first point?
Yes, sir.
Then the second point. Second point we are writing from that, this one is magnitude h of मतलब यहाँ पे अगर आप डायग्राम में भी देखेंगे तो here at 0 you have the value as 1, right? Getting my point? 0 के लिए magnitude response अगर आप देख रहे हैं यहाँ पे, so here if like h of e power j omega लिख सकते हैं और simply j omega लिख सकते हैं. In some book they are written as e power j omega, in some book it is written as only j omega, right? So if you look at into here, the value of 0 is again 1. Next value. Next, if I take at omega equals to omega c, at omega equals to omega c if I am considering, तो क्या होगा वैल्यू? कोई बताएंगे मुझे? So what is the value of this? Magnitude h of j omega c, right? मैग्नीट्यूड एच ऑफ जे ओमेगा सी और ओमेगा इक्वल्स टू, वी विल राइट इट एज, कितना होगा वैल्यू उसका?
1/√2.
यस, इट इज 1/√2, क्योंकि अभी यहाँ पे हम वैल्यू लिख रहे हैं ओमेगा इक्वल्स टू ओमेगा सी, सो दिस इज ओमेगा सी एंड ओमेगा सी, सो दैट आई विल राइट इट एज इट इज 1/√2, 1/√2। तो इसका 1/√2 का वैल्यू कितना है आपका, विच कैन बी रिटर्न एज व्हाट? At omega equals to, we are getting it as 1/√2. What we can call it is, just write one line, magnitude h of j omega c equals to 1/√2 at omega equals to omega c for all finite n value, for all finite n value, that is, we can call it as, that is, if I take a 20 log of this 1/√2 or magnitude h of j omega c, क्या होगा वैल्यू इसका? और दिस इज इक्वल्स टू, इफ आई टेक 20 log of 1/√2, कितना होता वैल्यू? एनीबॉडी? What is its value?
-3.0.
It is minus 3.01 dB, we can write it is, बराबर? तो हम -3 dB लाइन बोल रहे हैं, हम पता है आपको, राइट? सो इफ यू लुक एट इनटू दिस डायग्राम अगेन, सो इफ आई टेक ओमेगा इक्वल्स टू ओमेगा सी, यहाँ पे ओमेगा सी वैल्यू है, तो अपना वैल्यू क्या आ रहा है? द वैल्यू इज 0.107, that is 1/√2 equals to 0.707. So that point we are calling it as the -3 dB point value. जैसे कि आपका सपोज इफ वी हैव लाइक आरसी कपल्ड कैरेक्टरिस्टिक्स, एम्पलीफायर कैरेक्टरिस्टिक्स है, तो वहां पे आपको अगर बैंडविड्थ कैलकुलेट करना है, सो देयर हाउ वी आर कैलकुलेटिंग द बैंडविड्थ? कैसे कैलकुलेट कर रहे हैं? हाउ यू आर कैलकुलेटिंग द बैंडविड्थ? कोई बताएंगे मुझे? ये आपका आरसी कपल्ड एम्पलीफायर का कैरेक्टरिस्टिक्स है, राइट, दिस वे। तो इसका अगर मुझे बैंडविड्थ कैलकुलेट करना है तो क्या करेंगे हम? यहां पे एक लाइन डिसाइड करते हैं, बराबर? यस और नो? हेलो, आर गेटिंग माय पॉइंट?
Yes, sir.
तो अभी इसका ये पॉइंट क्या बोल रहे हैं हम यहाँ पे? व्हाट इज दिस पॉइंट? 3 dB लाइन बोलते हैं ना हम, पता है क्या आप लोगों को? सो दिस वी आर कॉलिंग इट एज लाइक F1 एंड दिस वी आर कॉलिंग इट लाइक F2, ठीक है? तो ये F1 F2 डिटेक्ट करने के लिए हमें ये लाइन डिसाइड करना इंपॉर्टेंट है। सो दिस वैल्यू इज 1 एंड दिस वैल्यू इज लाइक 0.707, सो दिस इज व्हाट द लाइन वी आर कॉलिंग इट एज अ 3 dB लाइन, ठीक है? So that is, we are calling it as a 3 dB line, that we are writing it here. तो यहाँ पे at omega equals to omega c, we are getting the point as 1/√2 or simply 0.107. Then next, the third point, I'm writing it as 3. Magnitude h of j omega, magnitude h of j omega tends to 0 as omega tends to infinity, बराबर? magnitude h of j omega tends to 0 as omega tends to infinity. क्या मतलब है इसका? Can anyone tell me what is its meaning? Hello, am I audible? Hello,
Yes, sir.
Yes, sir.
ऐसा गायब मत हो जाओ यार, लाइक गिव सम रिस्पॉन्स, हाँ हूँ चलते रहने तो कुछ तो भी। Are you getting this third point? As
Yes,
omega
sir.
tends to infinity, the value of this magnitude h of j omega tends to 0. मतलब suppose आपका ये वैल्यू इन्फिनिटी है, समझो ओमेगा इक्वल्स टू इनफाइनाइट है, तो क्या होगा होल फंक्शन 1 डिवाइडेड बाय इनफाइनाइट आएगा. 1 बाय इनफाइनाइट वैल्यू इज व्हाट?
0.
0. ठीक है. तो as the value of omega tends to infinite, the magnitude h of j omega is tending to 0. This is one point again. Then further point you just write. Fourth point, from figure, fourth point you write, from figure we observe that, from figure we observe that as the order of the filter n increases, as the order of the filter n increases, order of the filter n increases, the Butterworth filter characteristics, the Butterworth filter characteristics is more close to the ideal characteristics, is more close to ideal characteristics. क्या मतलब है इसका? Is more close to the ideal characteristic. Full stop. Theoretically we can say that, full stop. Theoretically we can say that, theoretically we can say that in infinite order, in infinite order. Now let me clarify this point. तो यहां पे अगर आप n देख रहे, n equals to 1, suppose if order is 1, तो आपका लाइन कहां पे? ये लाइन आ रहा है. Getting my point? So this is your line. Are you getting? Then suppose if you take n equals to 2, then your line is this way, right? Then if I am going to take this n equals to 10, तो क्या हो रहा है? ये यहां पे आ रहा है. So that means the indication of this is what? Suppose if you have the value, so this way, that is, तो आपका ये ऐसा ग्राफ है, right? So आपका ideal graph is this way for low pass filter. Yes or no? Getting my
Yes,
point?
sir.
अगर आपका n का वैल्यू ऐसा है, एक वैल्यू ऐसा आ रहा है, if this is for n equals to 1, right? And again we are having like this is for n equals to 2. Suppose मेरा n अगर 10 है, तो ये ऐसा आ रहा है, right? So this is n equals to 10. So मतलब क्या है इसका? As the value of n increases, your graph is approaching towards the ideal frequency characteristics. Getting my point? Yes or no?
Yes, sir.
Okay, so this is what about the fourth point. And last point you just write. From equation 1, it is clear that, from equation 1, it is clear that, from equation 1, it is clear that the magnitude h of j omega, magnitude h of j omega square decreases, magnitude h of j omega square decreases monotonically, as omega increases, क्या मतलब है इसका? कोई बताएंगे मुझे? लो पास फिल्टर का रेस्पॉन्स आप लोगों ने देखा है, राइट? तो ये यहाँ पे जैसे जैसे आपका वैल्यू ऑफ ओमेगा इंक्रीज होते जा रहा है, तो ये वैल्यू ऐसा डिक्रीज होते जा रहा है आपका, तो इसको हम मोनोटोनिकली डिक्रीजेस बोल रहे हैं. ठीक है? सो दैट इज व्हाट्स इट मीनिंग. सो दिस इज हाउ we can understand the characteristics of the analog Butterworth filter from this diagram. So this is all about the low pass Butterworth filter characteristics. You may expect this as a theory question. So they will ask you like explain about the characteristics of the analog Butterworth filter, and you may expect 3-4 MCQ question on this particular topic. तो आप अलग अलग split करके उसको देख सकते हैं. So each point will give you as a MCQ answer here, right? So now let me take the attendance and then we will close. Okay. So let me see who is absent today. Just a minute. Roll number 1 is there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 23, 24, 25, 26. 27 is not there. 27. I'm just calling the absent numbers. Then 28 is there, 29, 30, 31, 30, 32 is there. 32 absent. 33, 34, 35, 36, 37, 38, 39, 40 absent. 41, 42, 43, 44. $51, $52, $53, $54, $55, $52, $53, $54 and $55, and then $56, $57, $58, $59, $60. $60 is absent. Then $61, $62 is there. 62, $62, $63, $64, $65, $66, I think is there on the down. No. $66.
64 आएगी सर.
Oh, आएगी. 67, 66 ना है ना? 67, 68, 69, 70, 71, 72, 73, 74, 9. Okay. Today's absent numbers are roll number 27, 32, 40, 52, 53, 54, 55, 60, 62, 63, 65, 66, 74. ठीक है? किसी का मिस हुआ यहाँ पे? नहीं है ना? Done. We'll close here. And tomorrow we will discuss like again how to find the order and how to find the poles of the system. We'll close the session here. Thank you.